Okay, so question 10 gives us a pattern 22, 17, 12, 7, and 2. Okay, so find the next term of the sequence. Okay, so honestly, we could even do this using a graph. Okay, but okay, because this is 1, 2, 3, 4, 5. So if these are x and these are y, okay, what we need to do is say, okay, what do I do to 22 to make it 17? Okay, so I subtract 5, and I just keep kind of subtracting 5. Now we need to find the next term. And so we don't actually need to do much thinking here. This is just simple. Do you understand what a term is? This is what is a term. That is what they're testing here. Do you understand what a term is? Okay, so if we say 2 minus 5, we have minus 3. That is our next term. Okay, now we want to know what is the nth term. Okay, so firstly, what do we mean by nth term? Nth term means Tn. So this is Tn is equal to T1, T2, T3, T4, T5. Do you see that? Okay. So let's use the skills we already have. Okay. And we're going to find out how to find the formula for any graph, for any pattern. Now we know that because it's going down the same amount, that is pretty much a straight line, right? Okay, so if we were to put it on a graph, because all these things line up, we want y to go up to 22. Okay, cool. So I'm just going to go 2, 4, 6, 8, 10, 12, 14, 16. Okay. Okay. So if we take that, we've got, we're starting at 22. I couldn't go all the way up to 22, but I can go up to 17. 17 is about there. Okay. Now 17 was where x equals 1. So where x equals 1, that is 17. Where x equals 2, y is equal to 12. Where x equals 3. Well, this is actually not very clear, but I can see that the graph is just not going to work out, because it's basically going to be a line that looks something like that. Okay? And so the line is going to look something like that, and that can kind of continue on forever, right? Unless it tells us that it's going to stop. So what we're working out is really just the gradient. Do you agree? So when we're working out the gradient, how do we work out the gradient? So we need 2 points. So we need 2 points, and we're going to say the change in y over the change in x. So let's check it out. Let's do the change in y. So let's do from all the way from, wait, let's use term 1 and term 5. Can we do that? Okay, so let's use our y coordinates at the top. So our y is 22 minus 2. And our x is 1 minus 5. Okay? So we've got 22 minus 2 is 20. 1 minus 5 is minus 4. Okay? So that leaves us with 20 over 4, which is minus 5. And look at that. Minus 5, which is our gradient, also happens to be our constant difference. So therefore, m is equal to the difference. Okay, now we know that a straight line is y equals mx plus c, right? Now, in terms of a sequence, we're just going to change these around a little bit. We're going to say Tn is equal to ax plus q. Okay? Cool? So a is going to be, Tn is going to be minus 5x. But then how do we find q? What would you do? Do you think we could maybe use substitution? So if we take our Tn is equal to minus 5x plus q, maybe there should be n, sorry. Okay. So Tn, let's use 3. So let's use T3. Okay. So n is going to be 3. Q we don't know. We know this minus 5. We know that term 3 is what? 12. You agree? Are you with me? Did I lose you? Okay, cool. So we're going to say 12 is equal to negative 15 plus q. We're going to move it to the other side because, yeah. So that's going to be plus 15 plus 12 is equal to q, which gives you 27 is equal to q. So let's work it out. We've got Tn is equal to minus 5n plus 27, which happens to be exactly what you wrote down. But do you know where you went wrong? You didn't understand what they meant by the nth term. So the only thing you were missing there was your grammar. Isn't that exciting?